Hi, and welcome to the next episode of Humans of AI interview series, where together with my guests from business and academia, we demystify what AI is and what it's not, hopefully making the whole concept a bit more digestible. Today, we are welcoming Alan Winfield. Alan is the Professor of Robotics Ethics at the University of the West of England in Bristol. He's also visiting professor at the University of York and Associate Fellow of the Center for the Future of Intelligence at the University of Cambridge. He received his PhD in digital communications, and then he co-founded and led APD Communications until taking up appointment at the University of Bristol. He co-founded also the Bristol Robotics Laboratory, and his research is focused on understanding the nature and limits of robot intelligence. So without further ado, welcome Alan. Hi Alan, thank you so much for accepting the invite. I would love to start by asking you how your journey with AI and robotics started.
With robotics, okay, well, I guess I've been interested in robots since I was a boy.
Mm-hmm.
You know, I read science fiction as a teenager, and I loved the kind of TV shows. You're far too young to remember TV shows like Fireball, XL5, and Stingray and Thunderbirds.
Oh, Thunderbirds, I know. Mm-hmm.
And that, you know, it was shows like that that really captured my imagination and got me interested in technology and robotics and such like. But I didn't actually start to do robotics until I moved to Bristol about 30 years ago.
Okay.
And with two colleagues, we set up what is now the Bristol Robotics Lab in basically 1992.
Okay.
So nearly 30 years ago. So it's really only in the last, you know, if you like, half of my life that I've been doing robotics.
Amazing. Okay, so let's play Mythbusters a bit. So we've all seen the videos of Boston Dynamics and their cool moves, parkour moves, or the pizza robots, right? It's all from mass media. So we've seen them like picking up objects, doing perfectly calibrated moves. Yet it seems that the ability to reason and understand the cause and effect links hardly exists yet, right? So it seems like the robots are actually steered mostly by human with a joystick. And what we don't see after the thousands cuts of the video has been taken, that those robots just basically break. And Rodney Brooks, the chairman of Rethink Robotics and the famous Roomba inventor, once said, everyone's saying robots are coming to take over the world, yet we can't even answer the question of when one will bring us a beer. So what do you think it's so hard to build, like why is it so hard to build robust robots that would perform well in a real life situations?
Sure. Well, firstly, let me say that the Boston Dynamics robots are remarkable machines, but actually they're wonderful examples of control engineering. What they don't have is very much artificial intelligence. And as you say, you know, it's the, you know, I'm fond of saying that we can build the bodies, but we cannot build the brains.
Yeah.
So we have fabulous physical machines that are potentially very capable, perfectly capable of fetching a beer for you, except that we don't have, and the key words are common sense. Now, on my blog somewhere, you'll find a blog post where I suggest the Winfield t-test of robot intelligence. It's very simple. It's also extraordinarily hard. So the Winfield t-test is, could you build a robot that could go into someone else's kitchen, like your kitchen right now, and make you a cup of tea? Answer no.
Yeah.
And and the reason is that robots don't have the common sense knowledge that you and I have. I mean, think about it this way. You know, imagine that you visit an elderly neighbor,
yeah,
and she's unwell, and you say, "Would you like to make you a cup of tea?" And of course, you know, she might say, "Yes, yes, please." You would have no difficulty, even though you've probably never set foot in her kitchen. You know what a kettle looks like.
Yeah.
You know, generally speaking, where the tea bags might be. I mean, you know, you might have to look a little into a couple of cupboards, but you know, and you know how to fill a kettle with water, which is a difficult. I mean, these are very. It's a combination of common sense, reasoning, inference, cultural knowledge, and also dexterity. So, you know, some robots have the dexterity perhaps to, you know, to, for instance, pour the boiled kettle, you know, the boiling water into a mug, but not overflow. You know, the judgment of how much water to pour in so that it's neither too little nor too much. Again, this is a difficult thing. I mean, these are tasks that you and I were competent in by the time we were teenagers. You know, probably not a 5-year-old, you know, would be safe doing that, but certainly by the time we're 12 or 13 years old, we could do all of those things. But there isn't a robot on the planet that could go into somebody else's kitchen and make them a cup of tea with the same level of instruction that you and I would accept. You know, how do you have your tea? With milk, without, strong, weak, and so on, you know. So the thing that's missing, I mean, the dexterity and the perception are still very difficult. Let me not underestimate the problem, you know, of perception, but they're not so far away. Whereas the intelligence, and in particular the real world intelligence, the thing that we call common sense, which actually is, I mean, my old maths teacher, you know, he used to say to me, Winfield, common sense is all but common. And I mean, it's true that common sense covers a lot of things. We don't actually have a good definition for common sense, but it covers cultural knowledge as well as real world physics knowledge, you know, the knowledge of what a cup of tea is, for instance. So you know, I think that we've got a long way to go, I think, before you have what you might call general purpose butler type robots that could make your dinner, or you know, or do the dishes, you know. And I'm not talking about special robots that are dishwasher. I mean, we have dishwasher robots, of course, but
it's very controlled environment, right?
Exactly, yeah. So so those are going to be a long time yet, and the big, I mean, Rodney Brooks is absolutely right. The big problem is the intelligence, and that's the breakthrough that we're missing. And I mean, of course, you know, machine learning is extraordinarily powerful and impressive, but I don't believe fundamentally that machine learning can solve that problem.
So what can solve it? What can solve it?
Well, I don't know. I mean, you know, there are lots of ideas floating around, and I have my own ideas, but the truth is nobody really knows.
Sure.
Sorry?
Share your ideas.
Okay, well, I mean, I've been working for perhaps the last, certainly 7 or 8 years on what I call robots with simulation-based internal models. Okay. So these are basically robots that have inside themselves a simulation of themselves and their environment. And that's, it's a bit of a difficult thing to get your head round, but I mean, I'm sure you're aware of this, Camilla, but roboticists like me use simulators all the time.
Yeah.
So we typically prototype our ideas, we test out our ideas in simulation, because typically programming real robots is time consuming and also expensive, because if a robot crashes, a real physical robot crashes, it might cost a lot of money to do damage. Mm-hmm. So typically we tend to use robot simulators. Mm-hmm. So the technology, and what's more, simulator technology is very advanced. So we have very good simulators that simulate physics, for instance. They simulate real world physics and dynamics and such like. Now, what I've been doing, I'm not the first person to do this, but not many people have done this, is to put a simulator of a robot inside that very robot.
Okay.
And then to make it work in real time.
Okay.
Now, you may be wondering, why am I doing this? What's the purpose of this? Well, the point is that if a robot has a simulation of itself inside itself and the world around it, then it means it can make predictions. It can ask itself, what would happen if I were to turn left? Mm-hmm. What would happen if I pick this thing up? Mm-hmm. What would happen if I bumped into a human being? So the point is that a robot with a simulation of itself and the world inside itself has the, if you like, the cognitive machinery mm-hmm. to anticipate the future. And I think a number of cognitive scientists, believe that the ability to anticipate what might happen and, if you like, model possible futures is a really important part of human cognition. I think it's probably a fundamental property of human cognition. And I believe it's extremely important to theory of mind. So theory of mind, you're probably well aware, is the name we give to this remarkable ability that we have to form beliefs about each other's state of mind. And theory of mind is also a predictive ability, because, with theory of mind, your partner or your child, you know them well enough that you can probably anticipate what they might be thinking. And you may well, just by looking, taking a glance at them, understand what they might be about to do next. Now, I mean, we can all do that to some extent for all human beings. So we have a very weak theory of mind for other human beings, but for people close to us, we have a very good model of how they behave. And that allows us to anticipate their needs. I mean, we get it wrong, of course, a lot of the time, because we can't do real mind reading. That's, telepathy is impossible. But with theory of mind, I think, with artificial theory of mind, I think we could build much, much more capable social robots. We'd have much better human-robot interaction. So really, the focus of my recent work has all been on that question: how can we build artificial theory of mind? Now, by building, and you must understand, of course, that these simulators that we have, even though they're quite sophisticated, they're still very simple. They're still, they still are a very poor abstraction of the world. I mean, we can model physics reasonably well, but what we cannot do is model human beings very well at all. So, this is a work in progress. It's a new You know, it's a new direction of work in cognitive robotics and particularly social robotics. But I think, and I'm not going to make any claims, but I think it might be part of the answer, not the whole answer, but part of the answer of providing robots with common sense.
Really interesting theory, but like you said, also humans are in a way predictable, right? Like when you are trying to read the mind of your close ones, you kind of know how they behave, right? So
somewhat predictable, yes.
I mean, predictable.
We're also unpredictable at times, which is what makes,
then you get it wrong.
kind of, but that's also kind of what makes life interesting, you know.
Yes, exactly. True.
Or it can make life interesting. Yeah.
So I know that the other, or like another area, or another challenge scientists face in robotics is long-term autonomy. So robots operating independently for weeks and months. So why is that?
Well, there are all kinds of reasons it's tricky. One is energy.
Mm-hmm.
You know, it used to be the case, I mean, it's still true to a large extent, that if you ask a roboticist what the three biggest problems in robotics are, they'll say energy, energy, and energy. I mean, now I wouldn't say that. I'd say energy, intelligence, and probably those are the two main ones. I mean, one of the reasons that we're interested in soft robots these days is because we'd like to be able to build robots that consume roughly the same amount of energy as you and I,
mm-hmm.
which is not very much compared with robots right now. Mm-hmm. But we'd also like robots to be no heavier, in other words, not weigh any more than you or I, mm-hmm. But be equally strong. Mm-hmm. In other words, we'd like to make robots that are light, as strong as humans, or at least, you know, not very strong humans, but you know, typically we think about robots that are as strong as a 14-year-old teenager, mm-hmm. the same height, but consuming no more energy. Mm-hmm. Now, why do we want to do that? Well, because if you have robots that are light and no stronger than a teenager, then they're unlikely to do you any serious physical damage. Mm-hmm. Whereas at the moment, you know, robots are made out of metal and plastic and are heavy and extremely energy costly. Mm-hmm. So, you know, achieving the energetic efficiency, if you like, of, you know, of human beings who, you know, consume 2,500 kilocalories. Mm-hmm. It's really not very much at all. I mean, you know, a robot will burn that in a few minutes, you know.
Okay.
So you know, energy, I think, and intelligence are two of the big problems. I mean, the problem of how to build soft robots, in a sense, follows from those.
Mm-hmm. So it seems like we are like the right path, or like the most likely path is that we are like trying to like simulate robots in an image of ourselves, right? So there is.
Yeah, I mean, that's a controversial point. I mean, personally, I'm not. I mean, I'm interested in human-robot interaction, mm-hmm. but I don't believe that robots should look like humans.
Exactly, and that's my next question. So that's the thing. Like, there are obviously scientific sci-fi movies like Ex Machina, which are showing that kind of robots. But there is this also phenomenon, which is called uncanny valley, as you obviously know, which makes people feeling uncomfortable around robots looking similar to humans. So you think like we should not pursue creating robots which are similar to us?
Um, I would say not ever, but I mean, the ethical concern I have with robots that look exactly like humans, you know, and typically we call these android robots.
Yes, androids. Yeah.
And there are some, you know, particularly coming out of some of the Japanese research labs, there are some amazingly lifelike humanoid robots, android robots. Yeah. But the reason I think that they are unethical is because if you see a robot that looks like a human, you expect that robot to then behave like a human.
Yes. But
they cannot, for all the reasons we've just discussed. So this creates what I call the brain-body mismatch problem. Now, the point is, if a robot looks mechanical, then you do not have, generally, you don't have a false expectation of how it's going to behave. If it looks exactly like a person, in fact, often a very beautiful looking, person, you not unreasonably will expect it to behave and act and react like a person, but it will not. You'll be disappointed. And I think it follows from, so my primary concern is not the uncanny valley, but in fact the problem of deception. It's the problem that we can be deceived. We are deceived, in fact, by android robots. But the reason I say never say never is because, eventually, I don't believe that there's any fundamental reason that we cannot, in time, build human equivalent artificial intelligence. Where I differ from many of my colleagues is that I think it's going to take much longer than other people imagine. I think we're talking about probably hundreds of years into the future, not, several decades. I mean, the problem is, of course, the predictions have been several decades for at least, the last 40 years. Yeah. So in the 60s, we thought by the year 2000, by the time we got to the year 2000, it was by the year 2030. And now I think it's by the year 2050 or something like that. So we seem to be always predicting about 30 years ahead that we'll achieve this. I think the problem, and we touched a little bit on, on the problem earlier on. The problem is so immensely difficult. And I think it's complicated by the fact that we do not actually have a general theory of intelligence. And I'm not talking about artificial intelligence, I'm talking about intelligence in general, animal intelligence. So, the way I like to think about this is that, we have very strong theories in physics. So in quantum physics, we have the standard model, the so-called standard model of quantum physics. And the model is so good that we invest hundreds of millions, billions of dollars on experiments, like the big experiments in CERN, particle physics experiments. The problem right now is that the world is investing probably more money, at least in private companies, in trying to build artificial intelligence, but we have nothing like the standard model, theoretical model in physics. So in other words, we're spending a fortune, as a taking humanity as a whole, yet we have no theory, we have no theoretical underpinning, we have no mathematical theory of intelligence. And I think that's a fundamental problem. So, and I'm not the only one, but I mean, some people think you don't need a theory of intelligence. I think, personally, I think it's mad. It's like trying to do science with no theory. And I think that's why, you know, a lot of the machine learning work that's going on right now is kind of directionless, you know, trying out things, you know, let's see if this, you know, and then when they do build an impressive system and you say, well, how does it work?
You don't know.
They say, oh, actually, you know, we kind of broadly know how it works, but we can't tell you why the AI made that particular decision. You know, if you take the famous move 37, you know, in the winning match of AlphaGo against Lee Sedol, you know, the Korean Go master, there's this very puzzling winning move, and nobody has a clue why AlphaGo made that particular move. So, you know, it's you know, we're sort of in the dark, really. We're trying to build intelligence without really understanding what we're doing and how it works, even when it does, you know, do amazing things.
Yeah.
Incidentally, of course, the energy cost of AlphaGo is immense. You know, Lee Sedol, you know, burned about the same amount of energy in a 2-hour match as you get from an egg sandwich.
That's crazy.
You know,
Google can afford it.
Well, exactly, that's right. So, you know, this is one of the reasons that actually only the biggest AI companies are pursuing the big machine learning projects, is because the energy costs of running an experiment are immense. You know, sometimes millions of dollars worth of energy. I saw one estimate that it, you know, some of the big natural language processing machine learning systems, the training costs and the optimized training costs cost several $1 million worth of energy just to power the machines, you know. Extraordinary.
But that's expected to change a bit, right? Like to become more available because the cost of you know, computing power is or like computing power is more efficient, let's say, right? No,
I don't think so. No, I mean, the problem is that I mean, you know, I'll be really impressed when someone demonstrates an AI beating, you know, someone at Go, but consuming no more energy. In order to achieve that, we need a fundamentally different kind of computing, fundamentally different. And again, I've got ideas on the direction we ought to be going in. It goes back to an old-fashioned of computing, which you may not have heard of, called analog computing.
Okay.
The point is that digital computers are extremely energy costly by design. Whereas, you know, natural computing systems like our brains are not digital.
What about the quantum computing?
Well, so far, quantum computing costs even more energy because, you know, you need to cool everything to extremely low temperatures, which essentially means you need big cryostats and cooling systems, you know, with very sophisticated. I mean, essentially, it's like doing low temperature physics. I mean, in fact, that's what you really are doing in a quantum computer. So again, it's really only governments and companies with very deep pockets that can afford to do that. Right. So nobody has really made a good argument, you know, that quantum computing will make any difference at all in the pursuit of AI. I mean, you know, I can see why quantum computing might be useful in cryptography and some, you know, communications type technologies, but I can't see how it can make any difference, especially when, you know, I go back to the point I made earlier, Camilla. We don't have a general mathematical theory of intelligence. So, you know, substituting one kind of computer for another, how's that going to make any difference if we still don't know what we're doing, really? Yeah.
So why do you think governments and the companies are not investing in research on the modeling, on creating
modeling.
on creating the theory?
Well, I think, I mean, some university, some research projects are. So, I'm part of a group, a wonderful group at Cambridge, the Cambridge Centre for the Future of Intelligence, which is Leverhulme funded. Nice. It's led by Hugh Price and it's a terrific group of people doing amazing work on thinking about these fundamental questions. They're not questions about artificial intelligence, they're questions about intelligence. And that's where, we really need to but I mean, and there are others in the world. So, but the point is that I think the commercial world sees a lot of money to be made in AI and is investing, billions of dollars without really caring whether there's, a theory or not.
Yeah, so they very much feel comfortable with trial and error.
Well, that's the only method that there is right now.
Yes, exactly.
We don't have an architecture for mind. It's really quite astonishing what we don't understand about what thinking is, what intelligence is, what cognition is. And of course, the big one is consciousness. We have no idea what conscious. I mean, we have some great theories and some, I think, some very plausible theories, some very, very interesting theories, but they remain theories. We don't have any models for these things. We can model very simple little bits of intelligence, but certainly not human intelligence.
So you think it will be another many years until we figure it out?
Yes, I mean, I think there's no fundamental reason that it can't be figured out. I don't. I mean, some people think that it's so difficult that and might even involve some mysterious properties, quantum microtubules or something like that is one of these kind of rather mysterious properties. In other words, there are people who think that animal intelligence cannot be reproduced without the same hardware. That is, neurons, essentially, living neurons. But I'm not sure I agree with that. I really don't buy that.
But what's their reasoning?
Oh, I've no idea. I mean,
you don't even want to hear about it. Okay.
Well, I mean, I've tried to understand these things, but I don't understand the thinking well enough to be able to give you an answer to that question. I wouldn't even try. But
right. I like your T-shirt, by the way. Is it something you've done? Oh, nice.
It's Responsible Robotics. So
very nice.
Which is something I'm believe in very strongly.
Very, very good. Okay, and the other area I know of your interest is biorobotics, right? So there's a lot of coverage about bio-inspired therapeutic pets, like in Japan. It's very big for like elderly, which are alone, or like those with Alzheimer's illness. But do you know, like, there are any other examples which have or like can potentially have huge impact on the way we work and live, or these ones are the main ones which are like being created right now?
I'm slightly puzzled, Camilla, by your term biorobotics, because I mean, yes, I'm interested in biologically inspired robotics,
yes.
But actually all robotics is biologically inspired in a way. It's and the kind of I mean, I'm not doing so much work in this area right now. I have one project, actually just one project, which is strongly bio-inspired. And that's a project where we're trying to evolve robots, not design them, but evolve them using what we call an evolutionary entry. So in other words, we're kind of modeling or imitating very crudely, I have to say, it's a very crude imitation of biological evolution, not natural selection, but artificial selection.
Okay.
Which of course Darwin first wrote about in the 1860s. So we're trying to evolve robots rather than design them by hand in a big project that is led from University of York called Autonomous Robot Evolution. So in a sense, that's not really answering your question. So the early part of my career, or robotics work, if you like, and including this new project, is swarmish. So I was interested for many years and did a lot of work in swarm robotics. And swarm robots are very, very much inspired by social insects.
Okay.
So ants and bees but more generally by self-organizing animals. So termites are another example of animals that self-organize. And the puzzle about those systems of animal systems is that, if you take a termite's mound, we know that there is no brain termite. There's no hierarchy. There's no architect. There are no workers. I mean, essentially, the termites, the termite mound, and all the amazing stuff inside it, like the air conditioning and the fungus farms and such like. All of that is an emergent self-organizing property of the hundreds of thousands of individual insects working together. And for many years I worked on the problem of how can you engineer a system of robots that self-organizes. And again, I was interested in swarm intelligence as part of the big question of what is natural intelligence. And swarm intelligence is a particular kind. I think it's almost a unique category of intelligence. And I've written about this in a number of papers, not a lot, but so I think, but to come to your question, I think swarm intelligence systems could be extremely useful for things like precision agriculture. So precision agriculture is a kind of agriculture where you look after each plant individually.
Yes.
So the idea is that you'd have a field and you would have a swarm of robots, generally quite small robots, and they would collectively self-organize to not only plant individual seeds, but to look after each individual plant. Collectively, they would know where each plant is, and they'd be able to figure out the individual needs of each plant. So, you wouldn't therefore need to necessarily water all of the plants the same amount all the time. You might need some herbicide for a particular, or pesticide for a particular plant. You might need some nutrients for a particular plant. So the point is that precision agriculture, which I think is very exciting, would be a way of increasing the yield and also allowing agriculture in land that is currently not available because it might be too steep, too rocky. You might have a field which has patches that are cultivatable, but patches which are not. So I think swarm robotics is a wonderful potential solution to that problem. Another one is search and rescue. So, and of course, this is the science fiction one, which I mean, some movies have this kind of thing in, where you have robots that would go into a collapsed building, for instance, in an earthquake,
Yes.
and would find survivors, would perhaps give them first aid, would apply, would actually give medical first aid as well. And so there are all kinds of, and there are projects in the world working on those kinds of swarm robotic solutions for search and rescue, fire and rescue, that kind of thing, emergencies. And then you have exploration, you have undersea exploration, you have planetary exploration, or it may be even things like, and this is kind of getting futuristic, swarms of autonomous. I mean, you asked me earlier about autonomous. I didn't really answer the question properly, but you'd have semi-autonomous spacecraft that would go and mine the asteroids for, for materials and so on. Yeah, I didn't really answer your question about autonomy. I mean, autonomy is quite hard and quite interesting, and I think there's a myth around autonomy, which is that the smarter a robot, the more autonomous it is, and vice versa. The more autonomous, the smarter it is. In fact, that's not true. So I think one of the most autonomous robots that we have in common use right now is the robot vacuum cleaner, like the Roomba you mentioned earlier.
Yeah. But it has
It's
flaws.
highly autonomous.
Yes.
Highly autonomous, but has very little intelligence.
Yes.
And generally, I think that highly autonomous and highly intelligent is not a good idea. And generally, generally speaking, we don't have very many very autonomous robots. Again, I think that's important. So generally speaking, the kinds of robots that we build right now are, they have what I call supervised autonomy. In other words, they might be quite autonomous at the low level. In other words, making decisions about what to do in the next few seconds. But the high level autonomy is entirely supervised. In other words, they're monitored, they're tracked, they're supervised by humans. And if we go back to my kind of little thought picture of a swarm of robots tending crops, I think that you would have a human shepherd. So those robots would need shepherding. And in fact, one of the projects I'm working on at the moment in the lab, well, when the lab's been closed, of course, for the past 4 or 5 months, but we have a project on nuclear decommissioning, robots for nuclear decommissioning.
Okay.
And again, we're interested in a swarm of robots that would be able to go into an old, disused nuclear power plant that needs to be essentially decommissioned, and it's called environmental remediation, and it's the process of completely recycling, separating kind of high-level waste for storage from low-level waste, which can be cleaned and recycled, and then reducing the whole site to a green field. And it's immensely expensive but necessary, and also very difficult. And one of the things that we're looking at in the lab with our colleagues, this project is led from the University of Manchester, colleagues in Manchester, Birmingham, and here in Bristol, is a system where the human supervisors of the swarm of robots, or call it a team, it doesn't matter, call it a team of robots that are actually inside the nuclear facility, this old nuclear facility. So the idea is that and this is what we're exploring right now, is that you would be wearing a virtual reality headset, and you'd have data gloves, and in your field of vision, you would see a simulated representation of the real physical robots and as much of the environment as they can see. In other words, as the robots explore the plant and reveal more of the real plant, then your image of what the robots are seeing gradually gets filled in, like color, like a color by numbers thing, where so you see what the robots see, and with your data gloves you can touch one of the representations of a robot, and that would pull up a kind of status information about the robot. You could instruct that robot to go to a particular place, or you might in fact be able to draw a circle around several of the robots and direct them all to go to a different place. So the point is, you'd be able to shepherd these robots in a very natural kind of way. It's really a combination of virtual and augmented reality.
Was it inspired by the civilization game? Kind of reminds me. Have you played?
Well, I guess. I mean, a lot of us are, in robotics tend to, I mean, even I play video games occasionally. Actually, I got that from my eldest son. So, but yes, I mean, and often the techniques that we use are not that far from video gaming, particularly kind of this new generation of virtual reality video gaming, although we tend to use more professional kit and very professional data gloves, because we want to be able to, as it were, manipulate the environment, the real environment, very precisely.
It sounds like you're having fun along the way.
Oh yes, we are. Yes, I mean so should you ever have the opportunity, of course, once once life is back to normal, then do come and visit the lab.
I will take you on that.
Delighted to show you around. Yeah.
Thank you so much. Okay, let's go further. So I don't know how much you've been exploring around the medical and nanorobots, but this is one of really interesting areas as well. So I've read that some of the things are already possible. So, for example, sending the nanorobots to the bloodstream to extend your immune system, so like to repair some things. And the next steps, like the futuristic vision, would be to perfect biotechnology and reprogram the software of life. And the ultimate dream of many scientists is that the robots will be able to go into the brain and provide virtual and augmented reality from within the nervous system, rather than from the devices outside of our bodies. So, what do you think of this vision? If you have any, if you research anything around this, and how would it, you think, affect the humanity and the quality of life we are living? Because the question with extension of life or like living forever is, where will we put all those people?
Sure. I mean, my first thought is that there are some profoundly difficult ethical problems.
Oh yes.
With that sort of science fiction vision.
Yes.
It might be wonderful, but the history, in fact, current, the world as it is right now is full of inequity, and and that inequity extends to healthcare. And I suspect the higher technology, medical science becomes, the kind of advances you've just outlined inevitably are going to be extremely expensive. And my fear is that they'll only be available to the rich.
Once, yes.
So I'm I'm a socialist, and I think that technology should benefit everyone in society, not just not just the wealthy. So I mean, I don't work in medical or surgical robotics. I know, we certainly have work in medical and surgical robotics in the lab. And one of my close colleagues, Sabine Howard, is working on nano robotics. So you should talk to her about the work she's doing.
Well, that will be very nice.
Invite her to do one of these.
Definitely, that's very interesting.
So she could tell you much better than I can about where we are, where the technology is, and where it's likely to be in the near future. It's, you know, as I say, I worry about the ethical problems, and so we have a wonderful spin-out company in the lab or from the lab called Open Bionics. You may have come across Open Bionics. They build. You should check them out. They build amazing, low-cost 3D printed prosthetic hands and arms.
Okay. Yes, I did. Yeah.
For primarily for children.
Yes.
And of course, you know, the work they're doing is highly ethical. It's a, you know, Open Bionics are a model of an ethical company, in my view.
Yeah.
But I do worry about prosthetics. For instance, you know, I think it's highly ethical to offer prosthetics for people who've lost a limb through illness or injury or whatever. But you know, every so often I read about athletes who are thinking about elective surgery to replace, you know, possibly a working limb, or maybe a limb that isn't working but might work. You know, they believe might work better, or they you know. I think you're getting into very difficult ethics territory there. You know, at the moment, of course, you wouldn't get such elective surgery, at least you know, not from you know, not from a kind of, you know, like the NHS or anything like that. But I think there are some very, you know, deep ethical questions, ranging all the way from whether it would be okay, you know, to have elective surgery to enhance humans, as it were, bionically or cybernetically. I mean, we already have cybernetic enhancements. So, so you know, a cochlear implant for people who are deaf is a cybernetic implant. We don't think of it as cybernetic, but it is. And it interfaces directly with you know, with the nerves, with you know, with nerves in the, you know, in the brain. In a very crude way. I mean, not in the kind of science fiction way that some people would like to imagine, but well enough, in fact, that, you know, that deaf people can restore with training some, you know, some hearing. But I think there are problems, as I say, of both what would be acceptable as a choice, and also the problem I mentioned earlier of the inequity of the highest end technology, medical technology.
Yeah, like you said, like people like to game the system, right? So how do you think, like, what can we do to prevent companies and people from abusing the power of robotics and AI? How can we make it ethical?
Well, by having regulation. Well, yes, with regulation.
How heavy? Like how strict would?
So you know,
I think I was losing you a bit. Yes, I was just saying.
Well, I think that, I mean, ultimately, you know, we are still, I hope, in a democracy, and in a democratic society, we society can make choices, and we have choices. And I think that one of the jobs of a robot ethicist or responsible roboticist is to, through public engagement and advocacy, help people to understand what the choices are. So, when I wrote my book, A Very Short Introduction to Robotics, one of the aims that I had in that book was to set out for anybody, it's a non-technical book, the kinds of robots that we both have right now and we might have in the near future. And one of the aims of that book is to help people make choices about what robots we want to have in society with us and those that we do not want. So I think as a society, we should be able to choose, and we should be able to lobby our politicians and say, look, these kinds of robots, we think we should have these kinds, but those kind we don't want. So for instance, we should be able to say to our politicians, we don't want lethal autonomous weapon systems. In other words, we don't want robots that make the decision autonomously about who to kill and when to kill someone. I mean, that's a fundamental principle, I think, that many roboticists agree with.
Yeah.
But there are other kinds of robots that we might think society might choose not to have, like driverless cars. How does society feel about a truck, for instance? When I described to friends of mine the idea of trucks, big lorries, big lorries with trailers on the motorway without a driver. Often they say, wow, that's great. I can't imagine that. I'd be scared if I was sharing the same bit of road with
something you cannot control, or like you cannot
something that is not being controlled by a human being.
True.
So again, that's a conversation that society needs to have, and I hope is having. And we then, as a society, elect our politicians and tell them what it is that we think is acceptable and what is not acceptable. The kind, to have as robots in society. I mean, there are all sorts of examples. I mean, I don't think we should have robot childminders. I don't think we should have robot teachers in schools. So, I'm not saying there is certainly a place for robots in society. I think society can benefit from robotics, but only if everyone benefits, in my view, not just, a small proportion of rich people. So I think that we should have equality of access to robotics. So if we have very good robots, for instance, for assisted living for the elderly. And assisted living doesn't mean the robot looks after the person. It means the robot supports human carers.
Yes.
So it's a team of humans and robots, where the robots do the dull, repetitive, heavy work. The humans do the human contact, have conversations and provide the social contact, which is essential. But again, if we have those kinds of robots, and I think we will have fairly soon, we should only have them if everyone who needs one of those robots can have one of those robots.
Correct. But there's obvious concern that there are some countries, like China, that might ignore those rules and precocious measurements for developing like ethical robotics and AI, because some countries have different standards and have different things as priorities. So how can we make sure that we as a society, or like even communities, how can we be protected from other countries as well abusing?
One word: regulation. So by having regulation about the kinds of robots that we regard as acceptable in this country, then what we're basically saying to another country, maybe China, it might be other countries than China, we're saying, okay, we're only going to buy your robots if they comply with our regulation.
Mm-hmm.
Simple. It's not that hard. I mean, we've had it for a long time, and we buy cars from many countries in the world, but they're not allowed to sell us cars unless they meet, UK regulation and standards on all, in many aspects of the car, are regulated, are standardized and so on for safety. All kinds of safety certifications and so on have to be met. The same should be true of robots. So by regulating robots, by having standards and having regulation, then we simply wouldn't buy robots that didn't meet those standards. We have the mechanisms in place, and we just need to use them.
So we touched a bit on, actually not a bit, a lot around the ethics, but what about the data itself? As you know, it can be biased and it can reinforce discrimination. So how do you think we can, you will say a regulation, but I'm sure like you can expand on that. How can we mitigate some of those issues?
Well, bias in machine learning systems, and of course in systems that have machine learning in them, is a problem of bad design. It's a bad design of the training data set. So the point is that the training data has to be carefully curated to make sure that it's free of bias. Now, I mean, some people would say, actually, you cannot, by definition, have training data that's free of bias. But that may well be true, and I'm not a data scientist. But you can certainly minimize the amount of bias, so you can remove the gross biases, that mean that systems will only recognize, white people, for instance, or middle-aged white men, or whatever it is, you can. So I don't believe it's impossible to minimize bias. You may not be able to remove it altogether, but it's about training. It's about curating the training data sets, which is really difficult. Now, it's expensive, and that's why, a lot of startups, the machine learning startups, don't do it, because it's hard and expensive, to very carefully curate rather the training data sets. Now, if systems are going to be used for in society, particularly government systems, then those systems should be procured. They have to be procured, but they should be procured through a very careful set of rules. So one of the things that the World Economic Forum, the AI group, which is led by Kay Firth Butterfield, has done, which is wonderful, is to produce a set of procurement guidelines for governments in the procurement of AI. So the point is that you shouldn't procure the AI in the first place if it hasn't been shown, verified and validated to meet standards of non-bias, for instance. But we simply shouldn't be using systems. We shouldn't buy the systems, and we shouldn't even be allowed to buy the systems, or government should, not buy the systems unless they meet those very high standards of engineering and certification, validation, and so on. So, really the answer to your question is through strong standards, regulation, and procurement.
Thank you. Okay, and just last few questions because I know that we are running out of time. The impact on jobs, the impact of AI and robotics on the job market. So, you know, like a lot of jobs that existed in the past last few 100 years were repetitive, and the humans were doing the basically being the robots, right? And those jobs have been replaced by robots, and right now it's happening. Like the new, let's say, revolution is happening. So if sorry, I lost my thought. So do you think, what do you think is going to happen to the job market as we are progressing with like semi or autonomous robots, which can take many of the like repetitive and low skilled market?
The short answer is I have no idea.
Perfect.
I think it's an extremely difficult call because, you know, history tells us that each phase of automation has, although it has certainly displaced some jobs, and there's no question of that. I mean, when industrial automation really started in earnest in the 1960s and 70s with robots, you know, on assembly lines and in warehouses, obviously the individuals who made cars by hand were replaced by robots. But what is nevertheless true is that the overall number of jobs increased as a result of that automation. Now, the question is, will the same be true in the next wave, or if you might think of it as the current wave of automation? And ironically, actually, AI, I think the current wave of AI automation is creating a lot of new jobs, but what worries me is that they're dreadful jobs. They are awful, awful jobs. So you mentioned humans behaving like robots, having to work like robots. Well, if you look inside some of the enormous warehouses, which are called fulfillment centers, essentially the humans in the warehouses are only there because the robots are not good enough yet. And essentially their jobs, every minute of their job is controlled by computers, by an AI. It's telling them where to go, what to fetch, what to do with it, what to do next, and so on. So the point is that these jobs are dreadful jobs. They're jobs that are dull, repetitive, and actually health harming. And also they're very low paid. So one of the differences between the first wave of automation, you know, the point is that car production line workers used to be well paid. So, you know, someone on a car production line in this country or in the US in the 1960s and 70s, you know, could buy a house, you know, go on holiday, buy a car, do all the things that you know we aspired to. The problem is that the jobs that are being created right now are insecure minimum wage jobs, and that's clearly wrong. It's clearly wrong. And what we need is more unionization, not less, more. And there's another side of that story, of course, which are the offshoring of dreadful jobs that are needed to do the things that the AI cannot do. For instance, it's called excuse me, AI tagging. So this is where you need humans to tag images, describe what images are. You know, or bits of images to create the training data sets for driverless cars, for instance, or tag speech and text to, you know, to train natural language processing systems. Now, these again are extremely low paid jobs. They're typically now outsourced, and it's a huge industry, outsourced to what I've seen described as white collar sweatshops.
Oh wow. Mm-hmm.
So the irony actually is that robotics and AI right now is creating lots of jobs. It's just they're terrible jobs.
Mm-hmm.
And I think that's appalling, given the amount of money, that the wealth that AI is creating. The AI companies can easily afford to properly pay those workers, and they should. Mm-hmm. I think it's a disgrace, absolute disgrace. Mm-hmm. And those companies should be ashamed of themselves, and the CEOs of those companies should be ashamed of themselves. Mm-hmm. Now, that's my current kind of, if you like, rant, if you like, about the current state of jobs.
Yes.
But I'm going to again come back to my earlier point about wealth creation and the wealth being shared by all. Mm-hmm. You know, the purpose of automation is that we should all be able to work less.
Mm-hmm. Are you getting to the general income, the universal basic income?
Well, I don't mind what it is, but the point is that you know, the idea of automation is that we should all work less. Mm-hmm. And you don't have to go back very far to find advocates. So, Keynes, you know, the economist in the 1930s and 40s, confidently and optimistically looked forward to a time when we would all work 2 or 3 days a week by the end of the century. Harold Wilson in 1965 gave a famous speech called the White Heat of Technology speech, where he also optimistically looked forward to, and this was not a sort of pessimistic, you know, neither of these guys pessimistically predicted, as it were, a reduction in the amount of work. They were not concerned with unemployment, because they believed and trusted that the wealth created by automation would be shared by all in society, so that people could in fact then work less and enjoy the same standard of life. That, of course, has not happened. It's not come to pass. Why is that? Well, because politics and because capitalism. So, you know, in my view, we do need wealth distribution, and I don't care whether it's through taxation or through a universal basic income. The point is that this amazing technology only exists because of our taxes. You and I and our parents have paid taxes which have allowed governments to fund research, and that research has resulted in the internet, in artificial intelligence, in robotics. All of this amazing stuff we've been talking about wouldn't exist without taxpayer funding. So I think that it's only fair, it's only right that the wealth that's being created, which is enormous. I mean, eye-watering amounts of wealth are being created and have been over the past, 10, 20 years. And that wealth needs to be shared by all in society and not just, benefit a small number of executives and shareholders. Mm-hmm. Because that is not what automation is for. Automation should benefit all in society, especially because we paid for the fundamental research that led to it. Mm. So sorry, I'm ranting.
No, it's very, very, very interesting.
I feel very strongly about these things.
No,
so the fundamental problem is not a technical problem; it's a political problem.
Mm-hmm, mm-hmm. Yeah. Okay. It's a lot to take on. So where do you think the whole AI and robotics is heading?
that's far too big a question, Camilla. I'm not sure I can do that.
Okay, in the next 5 years.
I mean, that's again, I don't know. I mean, I'm not very good at future prediction. Yeah, and also I've got another meeting in 15 minutes.
It's okay. Actually, we were supposed to finish like right now. Okay, so the last question. So should we? Is there anything which we should be concerned about, like right now, apart from what we've already discussed, when it comes to AI and robotics?
Yes, I mean, I think I've covered a lot of it. I think we need to be more concerned about the ethical impact of robots on individuals, on societies, on democracies, and on the environment. That's really important. I mean, the big thing that we're all facing, and you know, the dreadful legacy that we're leaving for our children and grandchildren is the climate emergency. And I think that we need to be thinking about robotics and AI in the context, the longer term context of the climate emergency, as well as the shorter term context of pandemics and of poverty and wealth inequality. So I would say to my colleagues, you know, and anyone who's listening, you know, if you're not worrying about all of those things while you're doing robotics and AI, then, you know, I'd urge you to
wake
worry.
up.
Wake up, that's right. Yes, wake up.
Okay, that will be all. But thank you so much. I really enjoyed this interview.
All right, will do. Yeah.
Thank you so much, and I will take you on the invitation. I will come.
All right.
Thank you so much, and have a lovely day. Thanks. Bye-bye.
Thanks, Camilla. Bye-bye. Bye-bye.